Look, I know it seems like all these panels are running right up against time, so we'll jump straight into it on introductions here. Have we got, there we go. Yeah, I'm Lachlan. I'm one of the co-founders of Revelo. Revelo helps US companies find, hire and pay remote software developers. And I know it's an AI crowd, so we actually do a lot of code, data labeling, RLHF, and evals for people that are improving their LLM's ability to write code as well. So guys, just to start it off, why don't we just have a quick intro and then I'll jump into the questions. Sanjay, do you want to kick us off?
So this works this way. So my name is Sanjay Yadav. I'm the head of engineering at Parlance Corporation.
Lead of engineers and designers at InfoBeans, working with clients.
Devin Billings. I'm Associate Director of Electrical Research and Development at Boston Dynamics.
Hi, I'm Sajid Hassan, AI lead at Microsoft Cambridge here, leading Office M365 copilots right now.
So, look, just to level set, what I'm going to do today is level set a little bit where we are today and then get the point of view of everybody looking on the future. So, Sajid, you're working with AI at Microsoft. How much has it impacted your team's work day to day at the moment?
Yeah, we can speak for hours on this. Yeah, tremendously, right? So productivity boost, efficiency gains, we feel like we are all empowered to do more now with less, with all these copilots that we're building. So, for example, as I mentioned, I'm working with the Office M365 teams to build various copilots like Word, Excel, PowerPoint, Loop, Forms copilot we released a few months back. So these are all legacy app-based copilots. And in terms of software developers, of course, GitHub Copilot, so that helps tremendously, to boost the productivity.
And then I think just to see the whole spectrum, I'm going to go with Devin and Denise. Devin, why don't you say the most advanced, impressive stuff that you've seen in AI, and then Denise, I'd love you to give a perspective of where most of your clients are sitting in their journey.
That's not the photo I sent you guys. Let's see, where is neural network-based AI technology helping robotics? It's completely kicked open the door to manipulation. And by manipulation, identifying objects, understanding objects' three-dimensional pose in the world, understanding grasp quality. It's just kicked the doors open for all kinds of manipulation.
And then I think comparatively, Denise, what do you see, like where are most of your clients in their AI?
I would love to say like every engineer is like Tony Stark with Jarvis. That's what I had in mind. And our client's like, hey, here are Copilot licenses. And the first thing I go is like, why aren't you using them, right? And the engineer's like, well, the user experience. So I have this request from all our engineers, like, I want better UX, I want more context, I want a real Jarvis.
And then Sanjay, I thought you said something really interesting, that the use of AI in software engineering teams at the moment, it's both overhyped and underhyped. Tell me what you meant by that.
Yeah, so it's overhyped because you do see a lot of people trying to use the technology to build something. But at the same time, it's been hard to get something that's working really well and then put that out in production, whether that be code generation or even a chatbot, for example. When it comes to code generation, the biggest problem that I've seen so far is having the accuracy in the code that is being generated. So there's still a lot of promise, but yeah, it's still overhyped in some ways.
Well, I'm going to use that as a point to look to the future. So
sure.
At Revelo, we've interviewed, I think by now, 20 or 30 VPs of engineering, and I've asked all of them the question, so where do you think software engineering goes as a career 5 years from now? And every one of them and everyone here on the panel agreed, okay, it will be at a higher level of abstraction than it is today. But what does that mean in detail? So when you think 5 years from now, what does the job of a VP of engineering, a CTO,
Yeah.
or their software engineering teams look like?
Yeah. So I really think that different people are going to have different answers to this question. I have my own view into what's going to happen in the next 5 years. But when I think about this really deeply, I think where my mind is landing at is you are going to have software engineers who are really good fundamentally, have a great sense of system architecture, overall enterprise architecture, and are really just working with multiple agents, telling them, giving them instructions in terms of what to build. And I really see these agents evolving in such a way where it really is able to learn from all these open source code bases that are out there in this world and have the intelligence where, given a problem, it's able to come up with an end-to-end solution, not only just the implementation, but also test cases along with it, and is able to also monitor the solution frequently, right, and come up with recommendations on what should happen in terms of refactoring the code. But obviously, you need someone, a human being there to be able to really understand the recommendation that is being proposed by the AI model and then have it make the change. So that's where I really think in the next 5 years. So basically, it's, well, so I think the example that comes to my mind is it's sort of like a conductor who's running a symphony, right? The software engineer just becomes really at the high level a conductor with just like waving his hand, and then there are agents who are sort of following the instructions and doing what needs to be done. Sorry for the long answer.
I'd have to, Sadeep, what do you think? I mean, you're building these agents at the moment. Do you think that's an accurate view of the future?
Yeah, as I mentioned, before this panel, so it depends on where people are in their career journey, right? So, yeah, let's put an example. So let's say there are at least two types of search, right? If you think about, Bing, Google search, if you want to search something, right? So there could be navigational search or directional type of search. So navigational meaning that you don't know what you are looking for, you have an idea, and then you are actually searching and trying to get to your intent, to your ideal application or knowledge or any information that you're looking for. So that's one type, which is navigational. And the other one is directional type of search, meaning that you know what you're trying to find, you have an idea, you just want to use technology to find it. So similar thing applies for anywhere in engineering or science careers. So if you think about different type of terminologies that are used in engineering careers, right? Like AI engineer, data engineer, ML engineer, so I lead the applied science teams. So now with AI, what's happening is the line between all these different roles are getting less blurry, meaning that you can really upskill yourself, very quickly. You can identify or find the answers that you're looking for using some of these copilots. So in terms of coding, you should be able to find, if there is a bug or, what's going wrong, explain the code, refactor the codes, things like that very easily because it's, structured learning. But can you really solve a problem in terms of if it requires more reasoning and planning? So that's the future we are heading towards, with GPT-4 or GPT-01 that are released before, so that's the direction with multimodal capabilities and reasoning. So LLMs should not be able to solve those, but you need not only multimodal capabilities, but also, bringing in the technology from the past as well as from the future, right, in terms of traditional machine learning. So just give you one example, then I finish in terms of intent, right? So the key bottleneck here is that how do these copilots know that what you want? How do you interpret the user's intent? This is very complex, right? So if you are a VP of engineering, you might be trying to make a decision on a $100 million project, right? So can we get some opinion from the copilots? Yes. But can you rely on it? No. You have to come up with your own judgment, right? So similarly, the junior software developers, they should be able to, upskill, learn, improve their productivity or efficiency in terms of coding. But how do we know if they can solve their problem at hand, end to end? That you still need to be involved in the loop. So that's why we're calling it copilots, because humans should be always in the loop.
And do you think we're moving to a world where software developer agents is a common part of everyday work, or do you think that mostly it'll be something built into the code editor or something like that?
Yeah, so that's the hardest question, that we are, trying to solve for every day. How do we know what's the ideal user experience, right? Should it be seamless, where it's within chat? So you basically, if you think about all the tools that are being out there right now, starting from ChatGPT, mostly they're within the chat interface, right? Even GitHub Copilot supports that, right? So having someone always with you, so it's like pair programming type of thing, that can help you anything you need, but as a second opinion and things like that. Now, can you make it fully autonomous, right? So that's the future, but then how do you get there? So that's the journey we need to take in terms of how do you test those kind of systems, right? So you need lots of data. You need really also lots of manual evaluation with, so many software developers themselves. Is it really functional or not, right? So that's the challenge, in terms of verifying and validating how far we are.
And I think to branch out from software engineering for a second, Devin, there's an argument that I think a lot of people struggle to get their head around, which is, okay, software engineering is much more complicated than a lot of manual tasks around the house. Everybody seems confident we can make a software developer, or 80% of that. So why can't I do basic, like what's the barrier between being able to build basic machines to help me out in the physical world?
Well, okay, I'll answer that, but as you were talking, I wanted to comment. I feel like VPs of engineering for AI companies are maybe going to spend a lot of their time managing limited access to hardware processing.
Yeah.
Because I'm here at this conference, I'm a hardware person. This looks like exponential growth of AI technology. And when I work with software teams, software engineers are conditioned in this sort of continuous release, continued development fashion, and they're often kind of caught off guard when they're confronted with the limitations of hardware build timelines. So thinking macroscopically here, all of this industry building all these AI applications, I can't help but sort of question how will data centers grow quick enough to support it all?
Well, that's actually great. You expand it. I mean, the next area I wanted to kind of investigate is, all right, we roughly agree on what the future looks like, but at the moment, outside of GitHub Copilot, maybe Cursor or a couple of others, that's the major impact that's happened. We're still not close to the future that we all see. You think the biggest barriers are hardware and hardware restrictions. Do you think that'll continue to be a barrier for the next how many years?
I mean, I suspect for the next decade, we'll be managing that. All of us will be managing some element of that. And I was at the Amazon Dash Cart talk, and he's dealing with this very interesting analog to all this, which is what set of code runs on the cart versus in the GPU in the closet. Our kind of robots have that problem very sort of acutely. And I think, I don't know, I suspect all mobile devices will have an interesting same problem, and I don't know, I forgot your question.
You think that? No, I'm talking about, I think a lot of people are in the same situation where we all are looking at roughly, some details are different, but roughly the same future for software engineering. But we're not yet there. We're trying to map out, what's the barrier. Denise, I thought you had some interesting opinions on
I just
Again,
want
more
to
basics.
piggyback off of what everyone said, is that we talk about the future of engineering teams. And of course, I do this session with our engineers, just talk about philosophically. Then I realize that the first thing I want to deal with is the existential crisis. Like, some of them do have that. And I want to take a different stance and say, well, you should have an existential crisis. If you're not a critical thinker, if you're not a T-shaped engineer, that you look at hardware, like DevOps, like you need to know data, UX, everything. So I think that's, the other perspective is like, really even with Cursor, Copilot, like what they're using, they won't really want to tell me that, but they're doubling their speed in coding and preventing steps by refactoring early. I mean, the reality is they are still coding, heads down, but the ones who survive, so they're the solution architects. They know product strategy, they know how to talk to the business. So I took a different perspective as a leader and think, I shouldn't think about efficiency, I should think about what more could you, so they definitely do a lot more and satisfy client, exceed their expectations in ways that I didn't think about, and I realized I'm doing wrong measurements. It's not about efficiency, it's about what more you could do, and they have the creativity, they know UX, so that's something that I really believe in.
Yeah, I think we saw something very similar at Revelo, where when these copilots first came out, the most common question I got was, oh, won't your business shrink because all your clients will fire 30% of their workforce because now they don't need as many developers? But it's actually exactly the opposite. If your developers just started being more productive and they give you a better ROI, you don't cut the team that just got better at their job. You increase that team.
And I think the consolation again, well, look at what Excel did to accountants. You're getting a lot more of them.
Yeah. Sanjay, what do you think that means for the makeup of engineering teams in the future? Do you think it changes the profile of what the type of person that we're going to hire over the coming years?
Yeah, I do think that it changes the profile of the person that you want in your engineering team. So the makeup of the engineering team that I see in the next 4 to 5 years is someone really senior, someone who really has a very good grasp of software fundamentals, and is able to look through solution from an end-to-end perspective. And this person just really becomes someone who is sort of supervising, providing guidance, providing instructions to these AI agents in terms of what needs to be built, but has a great and a crisp understanding of what needs to be built, right? And also making sure that whatever output has been created really meets the standard and there isn't any inaccuracy there. And just going back to one of the questions that you had asked, I think the biggest obstacle that exists for us to get there is really around the accuracy of the code that is being generated by these AI models. Because yes, if you give it a simple problem, it can come up with something. But the problem that we're trying to solve is not that. The problem that we're trying to solve is, given a complex problem, how well can it come up with a solution, right? And once that's solved, and sure, I think it's going to be solved. It's just a matter of time. I don't think it's an if question. Once that happens, then this makeup that I'm talking about is possible.
Well, I wanted to use that opportunity to poke Sadid here and say, I hear that answer a lot, but Microsoft has access to more code than any other company on earth. So what do you think, like how could that be true, but yet us still not have solved the problem if Microsoft has access to so much code? To be fair, he's created the most popular developer product in recent times, so it's not a criticism of your work.
Yeah, sure. Yeah, I mean, it's a hard problem, right? So, yeah, I can quote Kevin Scott, like he says, like, with AI and with generative AI capabilities that we are building right now, so we are not saying that all problems should go away, right? We are basically trying to make the impossibles harder. Okay, so previously, a few years back, we even couldn't imagine that the things that we can do now, it's possible. So how can we, keep those impossible things into harder? Now, what does it mean? It means that you may not be able to solve everything for 100%, but all of us, we are empowered to solve at least 80% of them, right? So now the question becomes, how do we solve that last mile, right? That 10%, right? Now, imagine things like that. Previously, I've been in this field for 2 decades. People thought that robotics, right? So the manufacturing industry, that would be the first thing that AI could crack, right? Supply chain, organized shelves and things like that. People started working on that first, and thought that arts, science, coding, right? So that would be the last thing that would be impacted by AI. But so that's what completely we, right? It was complete opposite, right? What we see now. So why? Because we have lots of data on all this, text, code, and everything as you mentioned. But is it comprehensive enough that it's also thinking about our future problems? No, right? Problems are occurring every day, right? New problems are coming up, right? So the way to see it is that, my daughter, she's growing up with iPhone, with copilots, right? I didn't grow up with that. So all of us, our future generations, are also becoming smarter with these new tools, right? So as you become more smart, we are all empowered to do, those small things, the mundane tasks. But then we are now focused on more complex problem solving, which is, climate change. We can't even predict how to, when the hurricane is going to hit in Boston or things like that. So those new problems would also come in, right, in our focus. So those we cannot solve. So therefore, always there is new problem that we are focused on, and AI is going to take over the things that it can do well. So the definition of complexity and the expectation from AI keeps changing. So that's why, that's the gap that would always remain.
Yep.
Yeah.
No, absolutely.
I have a question. As we lead the future engineering teams, now I'm really want to leverage AI, and that means we have to have a lot more data sets to support the scenarios, the complexity that we want to solve. And I have a question for you, Devin. I think, and like hardware, we talked about like how do you create that environment where you have enough data for hardware engineers to solve difficult problems that you face? Because not an LLM today, like, right? That's
I don't know how AI is going to help hardware engineers anytime soon. But like in robotics, data sets are maybe the main problem, like the main limitation. Like there is no training data, or there is only simulated data. There's not real world data that exists for all this stuff. There's not multimodal 3D depth data to train models on to understand the pose of an alternator that we want to pick up. Mm-hmm. So I don't know, I imagine it'll be a big effort to generate all that data. It's like robotics is attempting, I think, to solve all the hardest problems at the same time because we've just picked like an application that we don't have any support for. So I don't know.
I think, and just I think we've got one more question, and then it's time to open up to the floor for questions there. But I think just to summarize, and so we've spoken about there's restrictions in code data, and because you always need new fronts, restrictions in robotics, healthcare. Sanjay, I imagine, is that the same challenge? Is data just across the board the biggest challenge, one of the big challenges for everybody?
Yeah, so in healthcare, of course there's the data, but then also being in healthcare is very challenging just because there's a lot of federal regulations that come into the play whenever you're working with the customer's data. So you gotta be careful how you use the customer data to train the model to solve a problem. Yes, it's possible, right? But then you have to get permission from the customers, and then also you have to go through some steps through anonymizing the data set. I would say in healthcare, using the data to really build an AI solution is far greater of a problem than any other business domain.
But isn't the problem is the opportunity?
Yes. Well, true. Yes.
And I'm going to throw that back at you next time you complain that it's hard to build these robots. So look, I think we have about 5 minutes. Should I open it up for, here we go. Is there someone to hand around a microphone? If not, I'll run it down. Yeah.
Hey, how's it going? Brendan Murphy. So as we know, generative AI, right, is just next token predictors, and it's been doing amazing stuff. My concern is that through the history of software development, we've always been tackling and embracing new languages as they've, gone viral, so to speak. So we have all this data that's written in JavaScript, Python, C++, these tried and true languages that have these massive data sets. How do we avoid stagnation when it comes to embracing a new language like Rust, where we don't have that kind of data set? And how do we continue to encourage software developers to use new data, new novel approaches, instead of just relying on what's been done before?
That's a great question.
I can try to answer that. So by the way, so that's the problem that's also in my mind. I think what we have right now is AI model, which is really good at solving the problems that's been solved before, right? But I think what we really want to have is we want to have a solution which, given a problem, can come up with, given a new problem, can come up with a solution. And the problem that you just, or the question that you're just asking is related to that. I think that's what's hard to solve, to Sadid's point. And I think that's where a lot of research is needed. And that's probably the biggest blocker if we go back to answering the question about blocker.
I was going to say, I think the key is, like, if we could use AI to analyze legacy code, right, which is humanly kind of impossible by one person, especially deal with huge client code bases, then they can spend their time and their creativity to figure out, like, the next step, and then use AI to help them create and curate. Oh.
Yeah, and I can add, like, so transfer learning is another way to do this, right? So we are all humans. We have all different languages. I don't expect someone coming up with a language that is completely distinct than anything that we have seen so far. So we can leverage transfer learning to quickly update the models. But that's why we are building these copilots that that we can speak it to using our own language, right? So English, we have those multimodal research we are working on. So that's the part. Like, we don't need to. Yeah, I shouldn't say that. We still need to learn programming languages because many of those legacy codes, as Dennis mentioned, depends on that. So, but still, you should be able to interact with our own language. So that's the future we are heading towards.
Yeah, so my name is Mark Zheng, and the question I have is actually concerning about the education of the engineer. Now that we have all these tools available to help them really speed up the writing of code, when you look at the education side, in terms of skill set as compared with, like, say, 5, 10 years ago, when you look down the future, what kind of different skill that likely will be more important for those new developers coming to the place? And in terms of team composition, are you going to be optimized optimally? Is that going to be all engineer, or actually there's some people who study English, for example, could be a very good player in the team? So that's two of the things that I'm wondering about. Thank you.
I think so. Just to clarify, the question was around how a junior developer is going to learn the right set of skills with copilots, and then does it change the set of skills that would make them effective? Is that correct understanding?
Yeah, in some fashion, that's right.
Yeah.
But I'm just trying to contrast with the previous kind of training that developed went through as compared in the future. What kind of difference?
I mean, it's an interesting question, right? Like, if the new model is a senior developer with an AI copilot, then you will eventually run out of senior developers.
But we had an interesting discussion over dinner last night saying, well, take a step back. Like, why did you pick CS as your major? Because really, when I ask the senior engineers, like, how about the juniors? They really say, well, do it for the love of the game first. Like, it's not about, like, I want to, get into CS, code, get rich, go to a startup. That's not the starting point. I think you had that perspective.
Yeah, absolutely. Now that you're handing the mic to me, all right, I'll add on to it. So I think, and I'll be honest, and I really think that the dot-com bubble that happened in 2000 really created a bunch of developers who really got into this business just because it paid well, right? I really think that the AI solution is really going to replace those, right? And the people who are really passionate about computer science, who really want to solve complex problem, yes, they are going to be there, and they're going to be able to do a lot more with less. So, not sure that answered your question, but I just want to add to what Denise was saying.
Why computer science is given a dependency at this point of time, right? 70% of the jobs of 2025 is not even known, right? You don't know that what job will you want, right? Because of the power of the AI. The question is that how you really enter into the skills development and right education model to prepare for the world.
Right, so the way I think about this is computer science is just a field, right? It's not a skill. I mean, if you, it teaches you concepts, which really makes you think about how to solve problems. So I think it is still relevant because it will teach your brain how to really go about solving problems. It's going to teach your brain how to, I mean, one of the things when I was in undergraduate, when I took my undergraduate computer science course, I was absolutely fascinated with computer architecture, right? The microprocessor architecture that existed, it was RISC architecture. I was just completely fascinated. How does an architecture like that is solving these big problems? Ultimately, it's turning everything into just two numbers, 1 and 0s, but it's solving a huge problem, right? That concept, that problem solving or analytical ability, I think computer science is one of the majors that teaches you that. So.
Can I ask you a question? Are compilers going to still be a thing in 10 years?
I don't know.
That was the question which was asked.
Yeah.
Right? Because you are doubling down on the syntax where you should be doubling down on semantics. Right? Because the real power of AI is to take that barrier which is bound into a semantic, syntax layer. I have to learn Python, I have to learn Rust, I have to learn XYZ. If it is a natural language expression in terms of my intent and the outcome, why is syntax even matter?
Just spit out 1s and 0s on the other end, right?
I think we have one more comment.
Yeah, just gonna finish with you guys all covered great points to that answer. So, but it's a continuous learning process, right? So you all need to upscale. So the team I'm on right now, so Microsoft AI Development and Execution Program, here we basically take in fresh graduates, and we have like 2 years of program where people actually solve real problems through this generative AI or any new tools that we are developing. So that has to be continuously done with academia, right? And also with our existing talent, we have like upskilling opportunities. So I guess what I'm trying to say is you really need to have that foundation to think through problem solving and to communicate with these models and agents, right? With whatever language you prefer. And that is what would make you connect the dots of how to solve those problems and grow forward.
And I make my engineers facilitate stand-ups so they can connect with human beings.
Guys, look, thanks so much for your time. We'll hang out at the booth a little bit afterwards if anyone has any follow-up questions, but thanks so much to the panel. Really appreciate it.